All right, so hopefully a lot of you guys have already gotten your vocab in your binder because we have vocab today. So green on the left, notes on the right. Okay, so continuing on with this this chapter, right? We now know there's two different types of probability. There's what's called theoretical and experimental, all right? But for the most part of this chapter, you're going to see that we're going to stick, because this is the actual math part of it, we're going to stick with the theoretical part. So the other day we talked about finding the probability of simple events, right? And it was very easy. And find out how many total items are. That's your possible outcomes. You put it on the bottom. And then the top, right, was your favorable outcomes. Basically like how if it was a game, how you can win the game. What do you have to spin? What do you have to roll? And that's however many that is. That's what you put on top. Okay? Today we're going to stick with probability. We're going to stick with a game, but it's not what's called a game with simple events. It's a game with what they called compound events. Okay? So that's what today's lesson is about, probability of compound events. It's a little more challenging, all right? So, probably your number one question in your mind is, what is compound events? Well, that's what we're going to start with. So our first word is compound events. Everyone? Compound events. You guys sound excited this morning. Here we go. Your book says, this is an event consisting of two or more simple events, okay? An event consisting of two or more simple events. So, for example, in your little box, go ahead and write that down. Spinning a 6, then rolling a 2. Spinning a 6, then rolling a 2. God bless you. All right. So, the other day, we had a spinner in front of us and said, what's the probability of spinning in this case, spinning a 6, right? And you spin it and you see how many sections there are, how many sections have a 6 on them, right? We talked about that, all right? Or another game is you have a number cube, like a die, right? You roll it and, we talked about their 6 sides and how many sides have a 4 on it, or in this case a 2, and okay, those are separate games. So what they're talking about here for compound events is when you have a game that you're playing, this is an example of what we're talking about today, you have a spinner in front of you and you have dice in front of you. And the game is this. You have to spin the spinner, then you grab the number cube and you roll it. The only way you win is if you spin a 6 on the spinner and roll a 2 on the number cube. That's the only way you can win. Okay, that's an example. See how the game is a little more complex. There's more than one thing going on to be able to win. All right, so that is what we're talking about today. And you'll see some other things. And it's not always a game format, but it's always easier to talk about games because it makes a little more sense when it comes to probability. All right, here we go. There's two things that are specific about that you're going to see in today's lesson that you really need to understand. The first is sample space. Everyone? Sample space. So this is the set of all possible outcomes of a probability experiment. The set of all possible outcomes of a probability experiment. So let's say you're rolling a number cube, right? Now, we all, not talking about the probability of it, meaning the fraction or percent or anything. I'm just saying, what is the bottom number that you'd put on the bottom? What is it, guys? 6, right? There's 6 possible outcomes. So when you're dealing with probability, you'd put a 6 on the bottom. Sample space is not how many possible outcomes, not how many. It is what are the possible outcomes. That's what your sample space would be. So for example, you're rolling a number cube, here's your sample space. 1, a 2, a 3, a 4, a 5, and a 6. Those are all the different things you can roll. That's your sample space. Not how many, it's just what exactly are they. So if you have 6 of them, what were those 6? That's what a sample space is. Okay, now the other thing is this. We are going to see here in a bit, we're going to see we have problems, and we'll take a look at it in a bit, but to find probability of compound events, especially to find the sample space, because that's what's most important, the most complex thing of compound events. To find the sample space, I'm going to show you a strategy. It's kind of a graphic organizer, okay, to use. All right, and we'll specifically use this graphic organizer today. And you've seen this graphic organizer before, probably used on other things. And that is a tree diagram. Everyone? Tree diagram. So this isn't just a tree diagram. It's a tree diagram that, of course, is used for compound events or to find a sample space. And that's almost exactly what the definition says. It's a diagram used to show the sample space. So it's kind of a longer thing to kind of squeeze in your little square there. You can write out in your margin if you need to, but most importantly, it's a way of showing all possible outcomes with compound events. We didn't need to do that when it came to probability of simple events because it was simple. There's just, there they are. There's all the possibilities, like, all those cards on our worksheet that were faced up. You got to see all the letters on the cards. You just saw them. There you go. You count them. That's it. You're going to find out that compound events are a little more challenging. So we've got to use this tree diagram. Okay. So once you get that written, go ahead and grab your worksheet. We're going to work off the worksheet today in our lesson. All right. All right, so let's go ahead. Let's start on the extra practice side. Extra practice. Okay, now, here's what I want to talk about. Remember what we just corrected, the homework we just corrected, right? It had tons of problems, and that's why we just talked about it, right? We give homework based off of the amount of time that we want you to practice it, not how many problems there are. So we had a lot of problems. That's because they were extremely quick kind of problems. However, take a look at this worksheet on both sides. 6 and 5. A total of 11 problems. Now, just a little heads up, okay? This lesson, because that tells you something. There's only 11 problems, meaning that these problems are going to take, each of them are going to take a little while, okay? So just kind of mentally prepare yourself that there's a lot involved with some of these problems. So I want to make sure that you guys know that ahead of time, all right? So, just a little reminder, always make sure that you read the directions, because like we talked about the other day with probability, the directions are really important and give you some kind of story, but you don't know what to do with the story, or maybe it's, maybe the story is within the directions. So here's what I want to do. We're on the extra practice side. Let's take a look at problem number 3. Okay, now, just to let you know, we are going to start with sample space because that's one of the harder skills on finding probability of compound events. All right, we're going to start with sample space, how many possible outcomes. Then after we practice that, then we're going to move to actually using it to find the probability. So stick with me for right now, all right, because the first section says for each situation, find the sample space. That's all they want us to do. Not to find a probability, they just want to see the sample space. Now, if we take a look at problem number 3, let's go ahead and close read this. And you're going to find that some of these problems don't have to do with games. All right, and this is one of those kind of problems. Here we go. Let's close read it. It says, making a sandwich from white, wheat, or rye, bread, cheddar or Swiss, cheese, and ham, turkey, or roast beef. Roast beef, right? So we're making a sandwich. We need to know what is our sample space, meaning how many possible outcomes. Meaning, in this case, how many different types of sandwiches can we make with those materials that we have to make a sandwich? All right. So here's what we're going to do. Okay. Step one is we are going to find, we're going to list, we'll call it element number 1. Okay, I'll just use the word element, but in this particular problem, the first element, of course, is the type of bread. Now, when I do this, I'm going to draw a tree diagram. Okay, the whole point of a tree diagram is a graphic organizer. We're going to organize our work where we can get a correct answer. You're going to just trust me. In a bit, you're going to see why we're going to do this. But here's what we're going to do. We are going to list the 1, 2, 3 types of bread across the top. When I do that, first, I'm going to really space them out. Okay, we're going to build a tree diagram. We have a bunch of branches coming off, and we want to give our branches enough space, for the tree diagram to branch out. So we're going to space them out. Then here's the other thing. I'm going to try to save you a little bit of time. If I have you write every single word over and over and over and over again, it's going to take you forever. This worksheet's going to take you a long time to begin with. Here's what I want you to do for today. I'm going to have you abbreviate these problems according to the starting letter of each. Now we run into a problem though. Take a look. White and wheat. I can't call them both W. If that's the case, we probably want to use maybe the first 2 letters. Well, there's a problem with that, right? WH and WH, that's also the same. So here's another thing you can do. Kind of like some abbreviation of states, if you've learned in 5th grade, sometimes they use the first and last letter. So first and last is WE, first and last is WT. So that's what we'll do. So here's what we're going to do. White, I'm going to list as WE. Wheat, I'm going to make a big space here, WT. And rye is nice and easy. It's by itself, it's R. Step 2. You guys will probably get the idea. This is element 2. An element, the second part of the second element, the second thing in this problem. Well, in this particular problem, the second thing I see here is the type of cheese. We have cheddar and Swiss. So C and S. Now, here's what I'm going to do. I'm going to make branches coming out. How many branches do I need to make for cheese? Just 2, right? There's 2 cheeses. So cheddar, and so I'm going to use a C and an S. So watch. Branch it out. C and S. I'm going to do it off of the wheat bread as well. C and S. And then I'm going to do it off the rye bread. C and S. So I'm going to pause for a second. I'm just going to share with you how to read this tree diagram. If we are making a cheese melt sandwich, all right? Slap some cheese and melt it on the bread, the toasted bread, for example. We would have a white with cheddar. We could have white bread with Swiss cheese. We could have wheat bread with cheddar, wheat with Swiss, or we could have rye with cheddar or rye with Swiss. There'd be 1, 2, 3, 4, 5, 6 different branches so far. There'd be 6 different kinds of melts, cheese melts that we can have, right, for lunch or dinner or whatever else. Okay. Now we're not quite done. Step 3. Okay. Here's what I'm going to put. I'm going to put repeat with a question mark. And the reason is because some may only have 2 elements. Some may have 3 or 4 elements, or maybe more. So you're just going to continue branching if needed. So in this case, we now have the type of meat, right? We have ham, turkey, and roast beef. Well, I'll use H for ham, T for turkey, but I can't use R for roast beef because R is standing for rye. So maybe I'll use RB for roast beef. So here we go. I'm going to branch how many times now for meat? 3 coming off of every single one of these. So here we go. 1, 2, 3. H, T, R, B. 1, 2, 3. H, T, R, B. Off the next one. 1, 2, 3. H, T, R, B. 3 more. You guys get the idea. H, T, R, B. 3 more. H, T, R, B. And 3 more. And we're done. H, T, R, B. Now, if I read this, right, if you go down every single little branch, you would have all your different type of sandwiches. So, for example, white with cheddar and ham. You could have white with cheddar and turkey, white with cheddar and roast beef. Or you could have white with Swiss and ham, white with Swiss and turkey, white with Swiss and roast beef. Or you could do it all over again and change your bread. And then after you get done with that, you could change your bread again. Right? So every single little branch is a different type of sandwich. So for example, if I want to find out how many are in my sample space, all I have to do is count the bottom branch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'd have 18 possible sandwiches that I can make with those elements of the sandwich. Okay? Now, here's what I would like you to do. Okay? First of all, don't write 18 because that's not what they're asking. Remember we talked about it in vocab, our vocabulary. I said, guys, sample space is not how many possible outcomes. It is what are the possible outcomes. So for example, right, rolling the dice, the possible outcomes were 1, 2, 3, 4, 5, and 6. That was your sample space. Now listen. And thank you those of you, just put down your pencil. Thank you those of you that heard me the first time. So here we go. The reason why I want you to put down your pencils because I want to clarify this. If you were to seriously do this problem the right way, your sample space would require you to do this. White, cheddar, and ham. Second sandwich, white, cheddar, and turkey. Number 3, white, cheddar, and roast beef. That's 3 of them. I have to do it 15 more times because there's 18 of them. How many of you guys want to spend your time doing all of that work, right, on one problem, okay, with 11 problems or 10 more to go, okay? Now listen, I'm not that mean of a teacher, okay? So here's what I'm saying. When we grade this on homework, your proper tree diagram will be good enough because what we know is every single one of these letters represent these, and if you do your tree diagram, every single branch would represent each one of these. So I'm not going to make you really do it properly. I'm going to let you keep the abbreviations in your tree diagram, and that's it. So when we grade this, basically on these kind of problems, your work is your answer. It'll take a while for us to grade, but when we grade it, it'll look just like that. Okay? So you don't have to do this. That's why I had you put your pencil down. I don't want people doing that and not listening to me and then getting home and thinking that I'm torturing them. All right? So no, you don't have to do that. This is your work. All right? And that's your answer. On these problems, we'll get into other problems, but on these type of problems, that will be it. Okay. Questions on that type of problem? I'm going to have you guys try one. All right, here we go. The problem I want you guys to try, sticking on the same page, I want you to do problem number 1. Problem number 1. All right, go. All right, how many of you need more time on that one? Okay. All right, 30 seconds. Go ahead, and when you share, guys, make sure, of course, you're sharing, right? Your answer is your diagram. So share your diagram. Make sure that they followed the rules of what we talked about with the diagram. Hopefully you guys space it out, because you'll know when you don't, it gets crammed in there, and then you lose track of where you are in your tree diagram. Okay. So 30 seconds. Go ahead and share with your neighbor. Go. Okay, here we go. All right, so I'm taking a look, and the first element, right, that's this first step, is the type of cone, ice cream cone. So it's waffle, plain, or sugar. So I'm going to list those three across the top, spacing them out. Waffle, plain, or sugar. Those are our cones. Second element is the flavor of ice cream. So it's chocolate, vanilla, or strawberry. So we already have an S, so maybe I'll use ST for strawberry. Chocolate, vanilla, strawberry. So off of each one of these, there are three of them, so I'm going to have three branches. Chocolate, vanilla, strawberry. Chocolate, vanilla, strawberry. Chocolate, vanilla, strawberry. And obviously, right, this would be like a waffle cone with chocolate, a waffle cone with vanilla, a waffle cone with strawberry, plain cone with chocolate, and you guys get the idea. So it doesn't say, again, it doesn't tell us how many are in our sample space. It's just say create the sample space, right? And like I told you earlier, that's all that you're going to be required to do on a problem like that. Okay? Questions on sample space and using tree diagrams. Okay, now let me show you how it relates to probability. All right? So let's go ahead and let's flip the paper over to the skills practice side. All right, here we go. So let's take a look at problems 1 and 2. Now, 1 and 2 actually go together. In my opinion, it should have been like 1A and 1B. Okay, so we're actually going to do the two problems together. So if we take a look, it says the spinner at the right is spun twice. Okay, now, first of all, number 2 says, what's the probability of getting at least 1A? So just let's clarify that really quickly. At least 1A. So can you win if you spin 1A? You have to spin it twice. Can you win if you spin both A's? Yeah, they're both, right? They're both winners. So, however, before we do that, we need to find out number 1. It says draw a tree diagram to represent the situation, meaning the sample space. All right? So, I want to clarify this, okay? Because you're going to see some in your homework like this. This is just a spinner. There's only one. But if you spin it twice, it's the same as if you were spinning another spinner that looks the same. Spin that one and then spin that one. It's the same thing. So each spin is considered like what we called earlier as an element. All right? So what I mean by that is watch. Now the other thing I want to talk about, just where you know, totally up to you. I prefer what I call the vertical tree diagram, but there is a such thing as a horizontal. So it depends what you want to do. You can do a horizontal tree diagram and it's just fine. Okay? So here's what I'm talking about. All right? In this case, step 1 is I'm going to go ahead. I'll just put tree diagram here. Okay? So I'm going to go through all the steps that we just went through earlier. Now this is, like I said, this is, I'm going to call this a horizontal tree diagram. So my first element is my first spin. Guys, what can I spin on my first spin? A, B, or C? A, B, or C, right? So we're not picking a food, right? An ice cream cone or a sandwich or anything, but we are playing a game. But my first spin is my first element. It's the first part of the game. So I can get an A, a B, or a C. Okay? I'm going to do a horizontal tree diagram. I'm just showing you how to do this. If you were interested, you could stick to what we did on the back. I like what's on the back better, but I'm okay with either one. Now, the second spin is our second element. Now, it's almost like we're spinning a second spinner, but we're not. It's the same though. If I spin this spinner again, what are our choices? Or what's the possible outcomes? A, B, C. You guys get it? So how many branches are coming off of this? 3. A, B, C. Off of this one, A, B, C. And off of this one, A, B, C. Now, I don't like this kind of tree diagram, but if you do, feel free to use it. It's the same thing. It's just going the other way. It's going side to side rather than from top to bottom. Okay, so here's what this means, kind of like on the other side. You spin an A the first time, you spin an A on your second spin. Or you can spin an A the first time and a B on your second, right? Or if you spin an A on your first, you can spin a C on your second. That's what that means. Or you could spin a B on your first, an A on your second. You say, but Mr. Wilkins, we already did that. No, we didn't. Because in this case, order does matter. A then a B is different than a B then an A. That's a different outcome. Okay, I want to make sure you're clear on that. B and then a B, B a C. You guys get the idea. So that's what that looks like. Okay? Now comes problem number 2. And I like I said, I'm doing this all in one problem. Okay? So we'll call this step 2. What's the probability of getting at least 1A? Here's what step 2 is. Write your fraction and put down the possible outcomes, just like we did the other day. Well, guys, that's what this is. Possible outcomes, an A and an A, an A and a B, A and a C. There's 3 outcomes. BA, BB, BC. Or you could just count your last branch like we did on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. That is our bottom number. There's 9 possible outcomes. Then remember, step 3 is what we did the other day with simple events. On the top goes our favorable outcomes. Well, remember, our favorable outcomes in this problem is this. At least 1A. So let's take a look and let's count how many favorable outcomes. Can we win if we spin an A and an A? Yep. How about an A and a B? At least 1A? Yeah, we spun an A the first time around. We won. How about an A and a C? There's a win. How about a B and an A? Yeah. A B and a B? B, C? How about a C and an A? Yeah. C, B? C, C? 1, 2, 3, 4, 5 favorable outcomes. Now, it doesn't say you have to write it in a percent and decimal form in this worksheet. So there's your final answer to number 2. This, of course, is your final answer to number 1, and we correct our homework. But they go together. Number 1 is basically doing the work for number 2. All right, so that ultimately is how you find the probability for a compound event. Okay? Now let me ask you guys questions, first of all. Questions? I'm going to have you try one of these. No questions? Okay, here's the one I want you guys to try. Flip it back over to the other side where we started. I actually want you to go down to the bottom. Try out problem number 6. Number 6. Okay? I'll go ahead and leave the spinner notes up here for you in case you didn't get good notes down. Make sure you get those notes down. Okay, but do number 6 on the other side. Okay, go. God bless you. Anyone need more time on that problem? Okay, all right. Checking you guys about 30 more seconds. Again, guys, that's actually the only type of problems we're going to do. So if you have it done, continue working on your homework. Okay, still need more time? Okay. Go ahead, turn to your neighbor, share your probability, and then, of course, back it up with your tree diagram. All right, go. Okay, here we go. So for number 6, it says find each situation, for each situation, find the sample space. Then find the indicated probability. So it was just like 1 and 2 that we just did. This game, though, isn't spinning a spinner twice. It's tossing a penny twice. So again, you can think of it as tossing one penny and then getting another penny and tossing it. Or you just toss the same penny twice. It's the same thing. Okay? Because the probability wants to know you only win if you toss tails twice. All right, so before we do the probability and find the favorable outcome here, we're going to go ahead and use our sample space, or find our sample space by using a tree diagram. So here we go. Tossing a penny, the very first time I can toss heads or tails. So heads, tails. That's my first element. The first toss, first simple event. There it is, heads or tails. Then my second element, or my second event, of course, is tossing the same penny again. So I can, on the second toss heads or tails. So 2 branches coming off, heads or tails, heads or tails. Now, if I actually wanted to list, because it's so small, if I wanted to list the sample space, it'd take me an extra 5 seconds. Heads, 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 tails, tails, heads, and tails, tails. There's my sample space right there. Okay, now they didn't ask for that. They did say find it, but that's our work. Then it says find the indicated probability. So probability, here we go. Total number of possible outcomes. 1, 2, 3, 4. There's your possible outcomes. 4 different outcomes. That's my bottom number. Favorable outcome, 2 tails. Well, let's see, out of these, there it is right there. There's only 1. And ladies and gentlemen, our probability for winning this game is a 1 in 4 chance. 1/4. Theoretically, all right? Theoretically. All right. Questions on that? Okay, now, I do want to give you guys a heads up, all right, on 2 problems, okay? One, the problem, since we're on this page, look at the problem right next to it. Okay? Now, I want you to write this number down, okay? Write down next to number 5, write down the number 36, okay? Here's why. Because when you build your tree diagram, in the end, you know how this one had 4 in the sample space? This one's going to have 36 in the sample space. So here's why I'm telling you this. Because first of all, I wanted to give you the number. It's not going to help you out too much other than just being able to check your work. So when you draw the tree diagram and you don't end up with 36, double check. All right, you should have 36. The other thing is, I'd really suggest use an extra piece of paper on this one. Okay, get that piece of paper. If it's lined paper, turn it sideways and build your tree coming off of the top. Okay, that will help you out. You'll need some space. You're not going to you're not going to be able to do it here. At least not where anyone can read it. Okay, so that's that one. Now here's the other thing. Well, actually, since we're on this side, I want to number 4. I just want to describe the car, okay? The first element is the color, white, black, or red. That's easy for most of us. But those of us that don't understand a car, there's 2 different transmissions. There's a standard and an automatic. Okay, an automatic is where the car shifts by you just put it in drive and it shifts itself. A standard is like a stick shift. You know, I mean, some cars still have a stick shift out there. Some people have it in their pickup trucks. You'll see a stick shift like in a race car most of the time where you can shift to different gears yourself. Okay, but bottom line is those are 2 different transmissions. And then on top of that, the engine, there's 2 different types of engines. They're saying a 4-cylinder or a 6-cylinder. So that's the last one. Okay, I just wanted to make sure I explained that where you don't misunderstand. Now, the one last one is on the skills side. Okay, and I'm not a big fan of this problem, but I'm going to try to make it clear to you, okay? It says choosing a vowel from the word computer and a consonant from the word book. Here's what this means. Pretend like you have 2 different bags. And the first bag has all of the vowels, only the vowels, from this word. Okay, that's what's in the first bag. They have little pieces of paper with all the vowels from this word. Then the second bag has all of the consonants from this word. Only the consonants from that word are in the second bag. and you're choosing, of course, 1 out of here and 1 out of here. Okay, so that's kind of what that is. All right, I want to explain that because there's a number of different ways you could take that. I just wanted to make sure I clarified that. All right, guys. Probability of compound events.